Conduction is a process in which heat is transferred from the hotter end of an object to its cooler end. Let's undertake an activity to understand this process better. Take an iron rod and attach iron nails on it with the help of wax. Now place one end of the rod between some bricks, as you can see on the screen. Now heat the other end of the rod with the help of a burning candle. As heating continues, the nails start falling from the left-hand side of the rod. There. So what did we infer from this activity? Well, this activity shows that in the process of conduction, heat flows from the hotter part of an object to the cooler part. Let's begin with the activity. Take 3 test tubes and label them as A, B and C. Place an iron nail in each of the test tubes. Now, pour some water in test tube A. In test tube B, pour water till the nail is completely immersed in it, and then add a small amount of oil to it. Now why do we do this? The oil forms a layer above the layer of water and cuts off the contact between oxygen and water, so that oxygen cannot dissolve in water. Now add anhydrous calcium chloride to test tube C. Anhydrous calcium chloride will absorb all the moisture present in the test tube. After this, close the 3 test tubes with the help of rubber corks and leave these test tubes undisturbed for a few days. After a few days, you will observe that the iron nail kept in test tube A will rust because it is exposed to both oxygen and moisture. On the other hand, the iron nails in test tubes B and C do not rust. And why is that? Because they are exposed to only water and oxygen respectively. So, we can say that both air and water are required for rusting to take place.
Let's assume you have an ore that has magnetic properties. For a moment, let's say this ore is hematite. However, this ore also contains certain non-magnetic impurities. Now the question now is, how will you remove these impurities if you want to get pure ore? The answer is simple, by using a magnet, and this process is called magnetic separation. Now let's see how the impurities are removed. To do this, we have a conveyor belt fixed on 2 wheels, but these 2 wheels are not similar. Notice that one of the wheels is magnetic in nature. So when finely ground ore is kept on the belt and the wheels are rotated, the ore moves towards the magnetic wheel. What happens then is that the non-magnetic particles start falling, while the magnetic ones remain attached to the belt. Why? Because of the magnetic attraction of the wheel. I told you that. Now, as the conveyor belt moves away from the magnetic wheel, the particles that were attached earlier, they start falling.
Have you heard of froth flotation process? No? I'll tell you what it is. It is used for the concentration of sulfide ores. In this picture, you can see a setup consisting of an iron tank, a froth collector tank, a hopper, and an agitator. In this process, a mixture of water and pine oil is taken in tank. The impure powdered sulfide ore is dropped in through hopper and the compressed air is blown in through agitator. The agitator is rotated several times. As a result, froth containing the sulfide ores is formed at the top of the tank and impurities settle down and are let out through an outlet at the bottom. There you can see it. Now this froth formed is collected in froth collector tank. After some time, the ore particles in the froth collecting tank start settling gradually. These are then used for further metallurgical operations.
Electrolytic refining is the most common method of purifying metals. In this process, anode is made of a large piece of impure metal and cathode is made of a thin sheet of pure metal. And what is the electrolyte made of? A salt solution of metal is taken as the electrolyte. Now, when current is passed through the electrolyte, the positively charged metal ions present in the electrolyte get attracted towards the negatively charged cathode. Alright? Now, when metal ions come near the cathode, they gain electrons from it and get deposited there. And as time increases, the cathode becomes thicker and thicker. As the metal ions from the electrolyte move towards the cathode, an equal amount of ions is released by the anode into the solution. So, as time increases, the size of the block of impure metal keeps decreasing, and the anode becomes thinner and thinner. The soluble impurities present in the impure metal block go into the electrolytic solution, and the insoluble impurities settle down at the bottom of the container below the anode. And what are these impurities known as? These are known as anode mud.
Let's say you have a rod of impure metal. Now I'll ask you a question. What will happen to the impurities when you melt this rod? Well, impurities, are more soluble in molten metal than in solid metal. Now, based on this principle, actually, an impure metal can be purified. Let's see how we do this. Take a rod of impure metal and clamp it. Now, place a circular heater around it such that only a certain part of the rod is heated. Now, continue heating till this part melts. Now, when this portion melts, start moving the heater forward. What do you notice? You will notice that due to this motion of the heater, the molten portion of the rod keeps moving. And what happens to the impurities? What did I tell you? The impurities are more soluble in molten metal. So they also move along with the molten part of the rod. And eventually, these impurities get concentrated at the end of the rod. Now all you need to do is cut this portion of the rod, and what you have now is a pure metal rod.
Have you heard of column chromatography? Well, what happens in column chromatography is, as the name suggests, first we need to prepare a column. Now to do this, we keep cotton at the bottom of a clean and dry glass column. Now on this, a thin layer of acid-washed sand is kept to support the column. The stationary phase, which could be alumina or silica gel or starch, mixed with a non-polar solvent such as hexane, is then placed. Now a thin layer of acid-washed sand is again placed on top of the stationary phase. The mixture to be separated is now dissolved in a highly polar solvent, which could be, for example, alcohol, and is introduced into the column. Now let's see what happens after some time. The components of the mixture separate and they form thin bands. The component that is more weakly adsorbed will move faster through the column and therefore will get separated first. And the component that is most strongly adsorbed, as expected, will be separated the last.